All right, so number 9, we have 3 parts. We're going to use the rule of signs to find the possible positive and negative zeros. Okay, so let's start out with that one. We have f of x, and that is equal to x cubed plus 2x squared minus 21x plus 18. Okay, and then f of negative x, we're going to change the signs of the odd terms only. So this is now going to be a negative x cubed. That's still going to be positive, plus 2x squared. This is going to change, positive 21x. That's going to stay the same, plus 18. All right, count how many times the sign changes. Positive, still positive. Positive to negative is 1. Negative back to positive, that's 2. So with my positive, it changed signs 2 times, so either 2 or 0. And then with my negative, we are negative, we go to positive, that's 1. And then we stay positive all the way to the end. So only 1 negative. You cannot subtract that by 2. So either 2 or 0 here, and then 1 here. So it looks like there'll be 2 positive zeros and 1 negative to give us 3. It could be irrational, but it makes sense to be 2 and 1. So 2, 0 here, and then 1 here. All right, so now part 2, we want to find upper bound and lower bound. Okay, so this is new. So this is our new thing. So the upper bound and lower bound will also help us to restrict the number of zeros that we have to use. So let me go through that rational zero theorem again. So we would take our constant term 18, leading term 1, and we would do 18 divided by 1. Factors of 18 are 1 and 18, 2 and 9, 3 and 6, and that will be it. This is just 1. And so we have this list, positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 6, positive or negative 9, and then positive or negative 18. So there are 1, 2, 3, 4, 5, 6 times 2. There's 12 numbers we got to try. We know from Descartes' rules of signs that 2 of them will be positive, 1 of them will be negative. So I know once I find that 1 negative, I don't have to keep trying negative numbers. Now, the upper bound and lower bound rule says this. You're going to, and you can pick any number. It doesn't have to be a number from here, but it can be. But you'll start with a positive number, so I'm going to start with upper bound. We're going to do synthetic division, and then the last row must be all positive. You want to find the smallest positive number that will give you all positive on the bottom row. For lower bound, and then 0 could be, 0 is positive, could be positive as well. 0 can be positive. I'm going to say 0 positive. All right, lower bound, we're going to do synthetic division, and we want the last row, and I'll show you what I mean when I say last row, to change let's just say last row alternate. This is or alternate positive to negative. Every other sign is going to be a positive or negative. 0 is either. 0 could be either one you need it to be. Okay. So let's actually kind of put this into practice so you can see what's going on. So we're going to be looking at our original polynomial, 3, 2, 1, 0, not missing any terms. So we have 1, 2, negative 21, 18. So down here I'm going to do 1, 2, negative 21, and 18. All right, so I'm going to try 1. I'm going to try the smallest number, 1. And I'm going to try to make the bottom row be all positive. Okay, so I'm going to bring this first number straight down, 1. 1 times 1 is 1. Combined, we get 3. 1 times 3 is 3. When I combine these, we will get negative 18. Okay, so right here, because this is negative, that means 1 is not an upper bound. All right, so I need to try a bigger number. So whatever happens, whenever I double, whatever happens here, I need it to be bigger than 21. So let's do a little mental math so we don't have to keep doing this. So if I did 2, that would be 2 here. That would give me 4. 2 times 4 is not going to be bigger than 21. So let's jump up here and say, what if I did 6? Now I could do 4 or 5 as well. So let's try 4. Let's just jump up and try 4. So let's say that I put a 4 here. And let's actually just do it. Let's just do 4. So these don't work. I'm going to try 4. So 4, that'll give me a 4 here. It's going to give me 6. 6 times 4, 24. And then that will give me positive 3. So positive, positive, positive. And then 4 times 3 is 12. And that gives me 30. So notice all of these numbers on the bottom, that's what we mean last row. Last row is here. The whole last row is positive. Positive 1, positive 6, positive 3, positive 30. I think that's going to be the only number to get me there, because 3, if this was a 3, say 3 times 5 would be 15. Yeah, that wouldn't get me there. So 4 is the first positive number, the smallest positive number, that when you do synthetic division, you get all positive on the bottom row. So 4 is an upper bound. 4 is your least upper bound, I should say. You got to find the smallest one. What this means is that from this list, 1, 2, 3, 6, 9, 18, you don't have to pick anything bigger than 4. So that means I only need to try 1, 2, or 3. And I know from this rule that only 2 of them will work. So out of 1, 2, and 3, 2 of them will work, and that's it. So these rules are more things that you can use so that you don't have to go and try all of these numbers. So 4 being my upper bound means that I only have to try numbers 4 or smaller. Since 4 isn't in this list, then we only have to try 3, 2, or 1. So it just restricts all of that extra work that you have to do by hand if you have to find all the zeros using synthetic division. So 4 is my upper bound. And then we want to find lower bound. So lower bound, we're going to be doing the same thing, but we have to pick a negative number, and we want the last row to alternate between positive and negative, positive and negative. Okay, so now I'm going to try negative numbers. So I'm going to start out with negative 1. I want to start there, and then I'll just go from there to another negative number. So we're going to do our original polynomial. So 1, 2, negative 21, and 18. And I want the bottom row to change positive, negative, positive, negative. So my first number bring down is 1. That's positive, so I want this number to be negative. Negative 1 times 1 is a negative 1. And when I combine, I get a 1. So this is not changing signs. That's one, that's positive, that's positive. So I need something bigger. So let me try negative 2. Negative 2. And I'm going to do my original. So 1, 2, negative 21, and then 18. So we're going to try negative 2 now. So bring down 1. Negative 2 times negative 1 is a negative 2, and then combine 0. So I got positive. This 0 can be either. It can count positive or negative. So I got a positive, I got a negative. Times 0 is 0, and then a negative. So this is 2 negatives in a row. So that's not going to work. So I need to go bigger. So let's try negative 3. And my numbers were 1, 2, negative 21, and 18. So negative 3 times 1 is negative 3. Combine these and we get a negative 1. So I got positive, negative. Negative 3 times negative 1 is going to be a positive 3. And then that's still going to be negative. All right, so this is not what I need. So I need something bigger than 3. We could try 4 or 5. Not really sure. I'm just trying to do some mental math and see how big we can go. Because you don't want to go too big and then you skip one that actually might have worked before now. So let's skip and let's just try 5 and see what happens when we put in 5. Oh, 5, negative 5, that is. It's going to be my box number. 1, 2, negative 21, and 18. 1 times negative 5, combine those, and that will give us negative 3. Negative 5 and negative 3 will give you a positive 15, and that's going to come out negative. Okay, so this doesn't work because I got 2 negatives. So let's go bigger. Negative 6, 1, 2, negative 21, and 18. And it's just a process. You got to keep going until you find it. I don't think there's a right way to really figure it out. Just guess and check. Negative 6 will give me a negative 6 times 1. Gives me a negative 4. Negative 6, negative 4 gives me a positive 24. It gives us a positive 3. So positive, negative, positive looks good. And then we multiply by negative 6 and 3. Give me a negative 18, and that gives me 0. So that works. Positive, negative, and 0 could be either. So I need that to be negative in this case. So negative 6 is the first negative number that I get to that gives me alternating signs on the last row. So that's what this little thing is saying. You need the last row to alternate positive and negative, or it could be negative to positive. It don't have to start out positive. Just whatever the first sign is, the next one needs to change all the way down. So our lower bound is negative 6. Now what this means is that out of all of these negative numbers, so negative 1, negative 2, negative 3, negative 6, negative 9, negative 18, I don't have to go past negative 6. So that means if there is a negative 0, it's going to be 1, 2, 3, or 6, something in this range. Nothing above that on the negative side. So we're going to put in our upper bound, which is 4, and our lower bound, which is negative 6. And then we want to use our answers from the previous steps with polynomial division and then the quadratic formula if necessary to find all the zeros. So Now we're going to find all the zeros based on what we just did. So from this list, upper bound was 4. So I need to try 1, 2, 3, and potentially negative 1, 2, 3, or up to negative 6. So that's what we're going to do. We are going to write those down. 1, 2, 3, negative 1, negative 2, negative 3, negative 6. All right. So I'm going to try 1 first. I think 1 was going toward that 0. 1, 2, negative 21, and then 18. Bring down my first term. 1 times 1 is 1, combine, give me 3. 1 times 3 is 3, combine, negative 18. And then 1 times negative 18 is negative 18, combine, we get 0. All right, perfect. So we had an x cubed, and then we drop down by 1, so we start with x squared. So this is 1x squared plus 3x minus 18. All right. So we got 1 positive, x equals 1. That's one of my zeros. Now let's see if we can factor this. Factors of 18, because 1 times 18, and then 1 and 18, 2 and 9, 3 and 6. We want to subtract to get 3. Be 3 and 6. 2 sets of parentheses. An x in the front of both. 3 and 6 at the back. Those are the numbers we use. First sign is my bigger sign. So first sign is my bigger number, 6. Gets the positive. And the second sign is negative, tells me they're different. And then when you set each of these equal to 0, we get x equals 3. And then set this one equal to 0, you get x equals negative 6. Okay. And so that hit right at my lower bound, negative 6, 1 negative number, and 2 positive numbers. So positive 1, positive 3. That is going back to this part. Okay, so remember part 1, how many positive zeros will you have? Either 2 or 0. And we did have 2 of them, 1 and 3, that's 2 numbers. And then the number of negative zeros by counting the sign changes was only 1, and we got 1 negative number, negative 6. And if you combine that with the upper bound and lower bound rules that we applied, so the upper bound, remember, was 4, so there was no positive number greater than 4. 4 was the biggest that you would go to. 4 wasn't in my list, so it had to be 3, 2, or 1. And notice 1 and 3 were those positive numbers. And then when we did the lower bound, okay, we found out that my lower bound was 6, so I didn't have to go past 6, negative 6. And that just happened to work out that my lower bound was negative 6. So that's how you use all of